that we use for EKG. It's exactly the same. Now, if you look at here, we have some dark lines that goes horizontally, and some other dark lines that goes vertically. We said that the horizontal lines measures time in seconds, and the vertical lines amplitude or voltage is how high, how tall these waves can go. That's basically what it is. Each of these large boxes contains small little boxes. So in one of these big boxes contains 25 small boxes because it has 1, 2, 3, 4, 5 times 5, 25. Forget about that. Nobody's gonna ask you how many little boxes there are. No. That's a waste of time. What they're gonna ask you is, what is the time on the horizontal line for a big block or big box, and what is the time for a small one? It's just the baseline. They're not asking you the all around diameter of the box. It's just the baseline. So let's go for the big one for the small one, because if you know the small one, then multiplying by the number of little boxes that are on the bottom, there are 5. So this will be 0.04 seconds. Be careful with the answer. It's not 0.4 seconds, it's 0.0. It's a very, very small number. So question for the exam. What is the time on a small box? 0.04 seconds. That's it. You got the answer. Move on to the next one. What is the time for a large box?
0.27.
Why? Because if I multiply 0.04 times 5, just multiply 5 by 4, 20. But you have a 0 right here. So that 0, you replace it by the 2. So 0.2. You can say 0.2, 0.20. And the exam is 0.20 seconds. Is that understood?
Okay.
Simple. Now, if we have all these, it says 1, 2, 3, 4, 5, that would be 1 second. Now, why is this important? Because we are going to use a method that is called the 6 seconds strip EKG. So every 5 blocks, big blocks, is 1 second. So how many seconds do we have in the entire strip right here? 1, 2, and 3. But for the calculation of the heart rate, we're gonna use a strip that has 6 seconds. So that will mean it has how many little blocks? 30, right? Because here are 5 times 3, 15. But if I use the 6 second method, I'm gonna have 30 big boxes. So that's basically how it works. So right here, that's the whole thing. This is the type of paper. So you need to know what the horizontal lines represents on an EKG, because it's time in seconds, and the vertical lines as well. And you have all the answers right there. Any questions? Let's talk about 12 leads EKG. All these EKGs that we do in our office are called 12 leads EKG. Why do we call them 12 leads EKG? Because we are going to record 12 little different locations from the heart. So the heart is going to be a look at, we are going to collect electrical impulses from the top, from the bottom, from the side right, side left, and so on and so forth, from the back, the front, everywhere. It's like with a camera, taking pictures of the heart from different locations, from 12 locations. That's what is called the 12 leads EKG.
Is that when you do the EKG, is that the amount of stickers they put on your body? 12?
We're going to talk about that.
Okay.
So it is just called 12 leads EKG for that matter, because we are observing, checking, photographing 12 different parts of the heart. Because we need to look everywhere to see what's the problem, right? What part is not contracting? What part is not doing the work? So that's basically what it is. Now, to answer the question, we apply 10 electrodes on the body, not 12. We're gonna get 12 different views of the heart. But when we apply the electrodes, those little stickers that we apply in the chest, arms, and legs, are going to be 10. Okay? We're gonna talk about that later on a lot, just to answer your question. Because that's a question for the exam. They're gonna ask you, on a 12 leads EKG, how many electrodes are you placing on the patient's body? And people think that because it's 12 leads, 12 electrodes, right? No, there are 10. Now, you might say, well, wait a minute. We're gonna see 12 different areas of the heart, but why do you place just 10 electrodes? Because some of those electrodes, all of these cameras are going to overlap.
Yeah.
They are checking the same area, but just from different point of view. So we will see that later. This is another question for exam, even though if it's not written. We have something that is called the rhythm strip. Now, what is the rhythm strip? The rhythm strip is, we use strip number 2. Later on, we're going to talk about all the leads. Lead 1, lead 2, lead 3, ABR, ABF, ABL, V1 through V6. So in total, 12 leads, right? That we are going to have on the printout. But then, they're going to ask you, one of these leads is going to show me almost every single wave on the electrical activity of the heart. Then I'm going to see them perfectly. It's the best view. Then we're going to use lead number 2. So, question for your exam. If the doctor asks you to print the rhythm strip, which one would you print?
2.
Lead number 2. Correct. Period. There is no other options. Now, if somebody happens to ask you, what do you print this lead number 2 to check for the rhythm? That's because it's the lead that shows most of the waves that they are clear, that you can see it, so you can notice what exactly is going on with the patient. Because the other leads are a little more overlapping, more confused, more tiny. Some of them you cannot see anything. You don't see the P wave, you don't see the T wave. You said, oh, it's disappeared. No, but on the other one, you can see it very clearly. So that's basically what it is. But the question that usually, if it's present 100% of the time of the exams is, if the doctor orders a rhythm strip, which one could be? Now remember, if you know one way of the question, you have to know the other end. They can ask you, instead of asking you which lead is the rhythm strip, they ask you lead number 2 is known also as what? The rhythm strip. Because if you do know one side but you don't know the other, then you memorize it. You kind of didn't understand it. So that's basically what it is. If I tell you that the flag of the United States has white and blue, and then I put blue and white, it's not the same. It's just the order. 2 plus 4, 6. 4 plus 2 is 6. So it's the same. So either way that they put it, you need to understand it. Because other than that, you will be like, you were guessing. That's the first thing that you say. Oh no, they just picked that up. Now, they switch these questions later on. You might be thinking that they're asking you exactly the same question, but you're looking for a different answer. No, it's the same one. Because they want to know if you really know what you are answering. Any questions? Okay. Sometimes we have electrocardiograms that prints only one strip. Only one of the leads will be shown on the EKG. Sometimes you might have two. See, one is a single, one has two. Here it has only one. Here it has this one and this one. So I can look at it. Is that understood?
Yes.
So once again, it's just for you to tell you. Nowadays, the beauty of technology is, well, I'm not gonna start speaking without knowing what machine they use here, right? But nowadays, they have a machine that prints the entire 12 leads in one page. Back in the days, there was like a big strip that was single. And then it's like the registered receipt that they give you, that they roll, and then you have to cut, and then you have to paste it to put everything in order. Lead number 1, number 2, number 3, ABR, ABF, ABL, lead B1, B2, B3, B4, B5, B6. That's a lot of work, right?
Yes.
I don't have no time for that, but the time that I put all this together, my patient is dead. So what we have now is, in one page, everything is going to come out. So for you, when you start working in a hospital and a clinic, that's what you're going to do, one page. You don't have to be cutting and pasting, putting this, oh, maybe I mix the leads, I put this, where, I misplace it, let's put it. No, now you have everything. So this is how it looks. So now, tell me, what is the P? What is the T? So reading an EKG is difficult. Because it's not going to be nice and sweet like we saw on the drawing, right? Oh, this is the P, this is... No. In a real EKG, this is what you're going to encounter. And that's why medical assistants don't need to interpret this. You just do the electrocardiogram, you just have the copy, the printout, give it to the doctor, and he will start enjoying that. Not you.
So we wouldn't even have to read it.
You don't have to interpret anything. You just put the leads, the electrodes connected to the machine, put the information in the machine, print it out, doctor, help yourself, goodbye, next. No, if you have to print it, if you have to interpret, this will not be the class for you. This is just basics, because this is what medical assistants do. Just to do the preliminary things, the easy part. See, you draw the blood, but you don't analyze the blood. You send it to the laboratory. Can you imagine I draw your blood, now I need to know what is your level of calcium, potassium, magnesium, cholesterol, and so on and so forth. That would not be a good job for someone who just go to the school for this little time, right? Then they have a lab technicians, they have a pathologist, microbiologist. You see those big words? That means that you went there, you're a doctor. You went there to do a lot of study, now to be reading, interpreting this. This EKGs is interpreted most likely for a cardiologist. Not even a regular medical doctor can interpret sometimes those. Because you are a cardiologist, you are a specialist. Now that I mention cardiologist, that's another question for the test. Who interprets an EKG? They put the medical assistant, the phlebotomist, the EKG technician. No. The cardiologist. Not even a medical doctor in general. Yes, we learn a lot of stuff. But the one who gives the last word is a cardiologist. So if I have a patient who has a heart attack in the emergency, who's going to be there? Doctors, nurses, technicians, cardiologists, at least one needs to be there, because he is the one that when the patient gets well, gets kind of in control, take them to my department because now it's my turn. So that's how it works, okay? So these are the 12 leads that are represented. It starts with lead number 1, Roman numbers, lead number 2, lead number 3. Then ABR, ABL, ABF. Later on, I'm going to tell you what is 1, what is 2, what is 3, where they come out with that. What parts of the heart are we looking at? What is ABR, ABL? What would those words come from? What does this letter represent? And then V1, V2, V3, V4, V5, V6 as well. And not only what do they represent, what part of the heart they are checking, but also where are they located? Where do we gonna place that so we can capture that particular part of the heart to see this particular lead? And if you see on the bottom, what lead do we see? Number 2. And what it says right here, the rhythm strip. That's how it works. It works a lot better. So usually that see, back in the days, the doctor asked you to do the rhythm strip by itself. And the machines, the EKG machines, the electrocardiograph, they are set up for that. Now we don't have to bother. We get the whole picture of the heart plus the rhythm strip attached to it. And it's always in the bottom of the page. So the doctor, instead of looking at any of these, first looks at this. And after look at this, and he sees some abnormalities right here, then look to the different parts where the abnormality is. Where is the part of the heart where this abnormality is shown? That's basically it. Interesting, right? So, intervals, we talk about intervals. Remember, what intervals do we have? PR interval, ST interval, QT interval. So we know what it is, right? So we're not gonna go over those things. Intervals actually are not asked much on an EKG exam or on the national certification. So it's not that you don't need to know it, but I already explained it to you. So when you measure the distance or the time between the beginning of the P and the beginning of the QRS, that will be the PR interval. So that's what we said, right? It's just that here give a more simple definition, right? But shouldn't be too worried about intervals, okay? Remember, all the things that I'm going and repeat a lot is because of your exam. After you pass your exam, nobody's gonna ask you any of these unless you become a cardiologist later on, okay? Other than that, you don't worry about this. But then you're gonna learn again, and you're gonna learn a lot more. But for now, just the basics. Let's talk about timing. PR intervals is usually between 0.12 and 0.20 seconds. So how many boxes is 0.12? How many little boxes?
2, 3.
3. Remember, it's 0.04 times 3, 12. And 0.20, how many boxes? Small little boxes?
5.
5. Because it's 0.04 times 5, 0.20. So we're going back again. So the interval has to be in between 3 little boxes and 4 little boxes. What happens if it is less? The patient has a problem. It's too fast. What happens if it is more than 20? It's too slow. It takes too long to reach to the other end. So extend, extend, extend. So that's basically what it is. See? What is measured from this place to this place? So we talk about the intervals. So no worries much about the intervals. Remember, what you need to understand later on is the P wave, how long it is, the QRS, how long it is, what is the distance, and the T wave. Then you will be kind of safe for your exam. Here it is, see? Everything is in red, easy for you to review it. Normal QRS between, so less than 0.12 seconds. That means it has to be between 2 little boxes and 3 little boxes. From 0.06 seconds to 0.012 seconds. Remember, 0.6 is like box and a half, right? Because each little box is 0.04. So 0.04 to 0.06, you need 0.2. So half of the little box. So it has to be in between these. If it is more than 0.12, we have a problem. If it is less than 0.06, we have a So these numbers, you need to know them for the exam because they like to ask these things. So what is the time of the QRS? You said, oh, look for that. 0.06 to 0.12 seconds. Pay attention, that is seconds, it's not hours, it's not years, it's not months. Because sometimes they give you the same thing, but they put hours. And they said, oh, wait a minute. Wait a minute. Don't let it fool you. Now, QT interval. We talk about the QT interval. So the only thing that you need to know about the QR interval is from where to go, from where to where is measured. That's it. Measure from the beginning of the QRS to the end of the T wave. That's it. Now includes all those things in between: the QRS, the ST segment, and the T wave. And that's what it says right here. Because it's whatever it has in between, right? In between the QRS and the end of the T wave, what do we have there? The QRS complex, the ST segment, and the T wave. So that's basically how it is. Anything else to not worry? Here it is, just for you to have an idea. Remember, PR, QRS, QT. PR goes between 0.12 to 0.20. This is the size, the timing. The QRS, 0.06 to 0.12, right? That's it. And the QT, no worries about that. Okay?
The QRS.
But it's more likely the distance between here and here and what is included. Include the PR, the QRS, the ST, the T wave. That's it. Here is all the definitions that we went through, so you don't have to kill much about. Remember, intervals, don't kill too much memorizing them, trying to know what it is. Just know where are located between the EKG. That's it. In between one cycle, what is the interval? What is the difference between the segment only, or if I take the whole interval? That's it. But that's for you to know when you're looking at an EKG. Everything else, we're not going to measure that. QT interval, we talk about that. Now it says right here, determining the intervals. This says count the number of small blocks. Yeah, that's what we do because we have all these little blocks, right? So that's how we're going to measure it for everything. See? Anytime that we measure this, we're going to count these little blocks because it's 0.04 to 0.12. If it is the QRS, then we look for if he meets the requirements. So simply, very simple. And the QRS and the T wave and all those, that's what we measure. We measure just the little blocks from the beginning to the end of that wave, and then we compare with the standard values. And if it doesn't meet the standard values, we know already that those are off charts, whether above the normal or below those normal ranges. Okay, so I think that we are kind of good. Here is the same thing, QR interval, measure at the beginning. Oh, I got this. Oh, this was just on practicals. We do it tomorrow, a little practical, so you know how to measure, count the little blocks, okay?
Okay.